So there have been a couple of questions about having some difficulties getting this gizmo to work correctly. So I thought rather than trying to type out directions, I would just create a short tutorial that would help you. So the first thing you need to do is there's two things you need to open. First of all, this one on top is the gizmo, the simulation, and then this one, the U283, is the actual worksheet along with the directions. So we're going to open both of these, and then I'm just going to use a split screen so that you can see what's going on. So here is the worksheet. Open that up. Okay, so we've got the worksheet open, or we'll have it open shortly. And then we're going to open up the gizmo. Click on Go. And I'm going to make this a little bit smaller so that we can fit everything on here. So it's not what I wanted to do. This. And pull this over. Okay, so that a little bit smaller, yeah. Okay, so we have, see that whole page. So here is the orbital. I want to just skip down to, I think the first page is pretty self-explanatory, so I'm going to skip beyond that and we're going to go to the next page. So the very first thing, when you get to a new activity, make sure that you read these directions at the top. It tells you usually to reset and then which settings you should have on. So I haven't started yet, so mine looks good. And we are going, excuse me, we want to have the grid showing. So I'm going to click on grid here. And then it says the velocity of a planet is represented by an arrow called a vector. The vector is described by two components. The correspondent, the I correspondent, or the J correspondent, excuse me, the I correspondent component represents the east-west speed, and the J component represents the north-south speed. The unit of speed is kilometers per second. So how do we describe the shape of an orbit? So in these directions, and it's very important that you look at all these directions because there's some really important things as far as the setting goes. So it says the distance used is the astronomical unit, which equal to the average Earth-Sun distance. Place the planet on the J-axis at r equals -3i astronomical units. So all we're going to do, this little purple dot is the planet. We're going to bring it over here so that it's at 3. Okay, and I know these numbers, if you're moving these around, the first time I did this, it was a little bit confusing for me as well. So what we're trying to do is just move this to 3. And if you can't get it right on 3, you'll notice on here r equals -2.96. That's good enough. Okay, the next thing, it says move the velocity vector, which is the purple one, so that v is equal to -8j. And then it says the absolute value of v is 8 kilometers per second. So really all you need to do is grab a hold of this, keep an eye over here where it has the absolute value of v is, right now it's 9.68, and we're going to just bring it so that it's at 8. And it's, if you look at the diagram, if you have it straight up or down, that's going to keep some other things right on the horizontal axis. And so if you keep it vertical, directly vertical, it will make your life a lot easier to make some measurements. So we're going to move this around, and we're going to keep an eye on this V, and we're going to get that as close, drag it to get it as close to 8 as we can. That's 8.87. I'm going to go back to 7.87. So there I have it. And what we're trying to do is make it look the same as what it's showing over here. Click play. Okay, so it says resulting vectors should look at the vectors at the right, and they do not have to be exact. And so mine right now are at -2.96, or my position is -2.96, so my vector is 8.87, which is very close to, whoops, I want it 7.87, that's a little too far off, so we're going to go there. All right, so then it says click play and then click pause after 1 revolution. So all we're going to do, click play, and we want to have on here, I think it was on the last one, it says to show the trail, so we would need to have that on there. on the previous page it said that. So we're going to click pause once it gets all the way around once. Okay? And then it says after one revolution, use the camera icon to copy and paste the grid. And so it doesn't show a camera icon, but if you click on tools right here, there's our camera. So we're going to take a screenshot, processing it, and then when it finally pulls up, then it says right-click the image to copy or download. So I'm going to copy this image, and then I just want to paste it over here. Now, your image is going to be much bigger than you want it to be, so you'll want to resize that. So Control V, there it is, and as I said, it's huge. So let's make it a little bit smaller. I'm going to resize. And I don't really want to have this whole thing. You don't need to have, if you want to just keep what's there, that's fine. It's not that big of a deal. Okay, so if you want to crop this out, you can. If you don't want to, you can just leave it in there. Either way is fine. So it says identify the shape. The shape of the orbit is an ellipse. The type of flattened circle, an ellipse has a center C and 2 points called the foci. So if you look on here, show the foci in the center. So if you click this, whoops, that's my picture. Get rid of the picture. And I'll click on that. So you can see the center one is red, and then the 2 blue buttons are those foci that is being discussed right here. So it says turn on that. The center is represented by a red dot. The foci are shown. So what do you notice about the position of the sun? So if you look at this, the sun is one of those 2 foci. So that's what you're going to write here. So I'm going to get rid of this line. And it's really helpful for me if you use a color different than the black. It's easier to find the answers really quickly. So the sun is one of the foci. Okay. So try several combinations of initial positions and velocity. So all you're going to do, reset, okay, and you're going to, let's see if we move this around. I'm going to grab onto that, maybe, and move it over to 2. I want to change the velocity. I'm going to make it a little bit longer. Click play. So if you do that, okay, reset it. Move, let's just move it over to the other side, okay? And we're going to shorten the velocity. Click play. Okay? And so it's asking, what do you notice? Okay? What do you notice about the orbits? Really what they're asking there is what is the shape? The orbits are always elliptical. The orbits are all elliptical. And what do you notice about the sun? Well, if you look at this, on every one of those, the sun was one of the foci. So the sun is always one of the foci. Okay, so I answered a couple questions. So what this demonstrates is Kepler's first law, one of the laws discovered by Johannes Kepler. First law states that planets travel around the sun in elliptical orbits with the sun at one focus of the ellipse. I'm going to skip ahead and let you answer question 4, and I want to move down to question 5. I'll do one of these for you, and then I'll leave the other one for you to do. So now you have to do some calculations. The eccentricity of an ellipse is a number that describes the flatness of the ellipse. Eccentricity is equal to the distance between the foci. So on this one, here's the foci, the sun is at 0, and this one is just before 2, so maybe about 1.75, 1.8. And then that's divided by the total width of the ellipse. So if we look here, one side of the ellipse is at 2, the other side is at 0, so the width of the ellipse is 2. So now it's asking us to put this planet, so we're going to hit this reset button, get all this off. Don't believe, I'm going to take these vectors off for right now, because I don't think that we know. Yes, we do. I'm going to put those back on, sorry. Okay, so what we're asking, or what's being asked, is this: move the planet to R is -5, so we're going to grab the purple dot, that's the planet, we're going to move over here to -5, okay, and to confirm that, we're looking here, R is -5, 4.98. Don't worry about this minus 0.05. That's immaterial. You don't need that. The other thing we need is a speed of -8, and that's our J value. And so if you recall from the previous example, what we're looking for is the absolute value of -8, which is 8. So we're just going to drag this until we get to 8, or as close to 8 as we can get it. 7.78. So there we have our settings, -3, or -5, excuse me, and then the absolute value of -8, which is 8. So -5, all we're doing, this first one, this position of the planet, is where on the, you know it is the x-axis more easily, and so that's what we're going to use that at. So when we do that, then click play. I'm going to speed this up a little bit just in the interest of time. And once it makes one complete orbit, then we can stop. And then we can determine what those questions are. So the first thing it asks is, what is the distance between the foci? This is not quite on the line, but we're going to pretend that it is. So here's one foci at 0. The other foci is at -2.5. So the distance between the two is neither negative or positive. It's just 2.5. So we're going to write 2.5. Okay. I'm going to put that in this other color. And then what is the width of the ellipse? Well, this one's at 5, this side, and then if we go over here, 1, 2, 2.5. So we've got 5 here plus 2.5, so the entire width of the ellipse is 7.5. Because we're going from -5 to +2.5. So what is that? 7.5. That is, whoops, if I can get that to go, make this blue, so 7.5. So then, what is the eccentricity? Sorry, I'm recording this at school, and we'll just wait for this announcement. Thank you. Okay, so it says up here to calculate eccentricity, it's the distance between the foci, which for our example, 2.5, divided by the total width of the ellipse, which is 7.5. So I'm going to pull up my calculator. 2.5 divided by 7.5. So for this example, our eccentricity is, and we're just going to go to 2 decimals, 0.33. is the eccentricity. I'm going to try to put a space in there. Whoops, wrong spot. Okay, so I'm going to let you do that second one. So you're going to move it -4, so reset. Drag this so that it's at -4. Okay, and you can either just confirm it by where you have it placed on the line, or you can look down here. So mine is at -4.03, which is close enough. And then we want the speed at -4. So we're going to look at this arrow, we're going to pull it, and then we're going to move it until we get this absolute value of v to equal 4, or as close to 4 as we can. So we're going to move that up. Keep going, 4.87, 3.87. I don't think we're going to get closer. And again, it says if the velocity or the vector is not exact, that's okay. Click play, and then you'll have to measure the distance between the two foci. I'm going to stop that. So one of them's here, one of them's here. What is that distance? And then you also have to calculate how far apart they are. And then you're going to answer those questions. Now, moving to the next one, we'll do one of these together, activity B. So again, click reset, turn off, show foci and center. So we'll reset. We're going to take that one off. And it says to put the planet at -5 and a velocity of -4. So we'll move over, -5. Okay. And then it says turn off the vectors, or we got that, click play, observe the speed of the planet. Okay, so we're going to hit play. Here we go. and we'll stop it again right there. So the question's at what point does it move fastest? When does it move slower? So if you look at this again, it looks as though it speeds up when it goes around the sun, slows down when it moves away. Okay, questions A and B. All right, so let's move on a little bit to this next part. So it's asking, based on, actually, let's go down to number 4. It says, click reset. Imagine a line connecting the planet to the sun. As the planet moves around the sun, the line will sweep out an area. Click play and then click sweep area and then record that area below. Then press sweep area 4 more times to complete the table. So we're going to reset, okay, and then we're going to go play, and then right here, this button, sweep area. So you'll notice, okay, then we're going to do it again, and we'll stop. So this area that it sweeps right here, 12.497, I don't know if you can copy that there or not, no. Okay, so we've got 12.497 times 10 to the 15th. Whoops. Oh, it was good. My computer froze up. So we'll try that again. 12.497 times 10 to the 15th. Okay, then you're going to click play again. Sweep area. You can stop. And what do you know? So you need to do that 5 times total. All right. Now, I think I'm not going to go into activity C. I think you can figure that out. If you don't, call me. I'd be happy to help you out. But I think most of the problems were coming from actually just being able to understand how to use the gizmo itself and how to get the settings correct. So we're going to stop there. I have students that are knocking on my door because it's lunchtime. So that's going to be it.